Welcome to clickmyproject.com.
Our product title is Indirect Field Oriented Control of an Induction Motor fed by a bidirectional Quasi Z source. Let us see about the abstract of our product. The proposed system design is a new closed loop speed control of an induction motor fed by a bidirectional Quasi Z source inverter. The speed control is based on the indirect field oriented control strategy. The IFOC is implemented based on a voltage pulse width modulation and with voltage decoupling compensation to insert the through state within the switching signals. A dual loop controller is designed based on a third order small signal model to control the bidirectional Quasi Z source inverter capacitor voltage. The proposed speed control method with reduced DC input voltage compared with the standard adjustable speed drives using voltage source inverter are able to change the motor speed from 0 to the rated speed with the rated load torque. The performance of the rotor proposed speed control method is verified by MATLAB simulation of a 15 kilowatt induction motor fed by a bidirectional Quasi Z source inverter. The simulation result during different operational modes verify the validity of the proposed closed loop speed control method. Also, the proposed inverter can be operated with simple PWM control and can be designed at higher switching frequency to reduce the volume of passive components. The proposed inverter can realize buck boost inversion and power conditioning in a single stage with improved reliability. In addition, the proposed implementation has the unique advantages of lower component ratings within this is simulated in MATLAB simulating environment. Next we see about the flow diagram of our product. In this flow diagram the input source is a DC supply because the main objective of the flow is the inverter function. So inverter means that convert DC to AC supply. So the input source is a DC supply. Then that DC supply is fed into the Quasi Z source network. That is a network. For example, Z source network that having two inductor and two capacitors. For Quasi Z source network, they having one capacitor and one inductor. And also the output of the network that connected with the inverter having MOSFET switches. And also the input source voltage is getting from the source and it fed into the voltage controller. In voltage controller you compare with the reference value, then is fed into the current controller, and also the current value is getting from the input side, and also that error value with compare with the current controller, then that is fed into the PWM generator. And also the IFOC indirect field oriented controller is getting some values from the output side, and then that processed is inner blocks that processed, then that fed into the PWM generator. Finally that PWM generator generate the pulses for 6 switches in connected in the inverter section. Then that switches is deliver the triggering signal, then that output is a AC supply will get. Then that AC supply is fed into the induction motor. Here we using induction motor rating is 15 kilowatt induction motor. And also the traditional AST system is based on a VSI, which consists of a diode rectifier front end, DC link capacitor and inverter bridge. It suffers from one common limitation and problem such as the obtainable output voltage is limited far below the input line voltage. Voltage drop can interrupt an AST system and shut down circuits, loads and process, and the performance and reliability are compromised by the VSI structure. And also for misgetting dead time common mode voltage, that are the problem is increase in the conversion method, that are eliminated by using of indirect field oriented control method. So the recently developed Z source inverter has a rectified that kind of problem. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB main window. After that we creating a new model file. After creating the new model file, we arranging the elements as per the circuit diagram and also the given flow diagram from the simulating library browser. In the simulating library browser we mainly use two kind of toolboxes. One is SimPower System toolbox, another one is the commonly used toolbox. From that toolbox we getting the elements and arranging that elements as per the given flow diagram. After that we click the run icon, then the simulation will start to run. After that, when the simulation is entered, then we open the scope is connected to the corresponding measurement devices. Then the output will be displayed in the corresponding area. So the first one is the SOC, battery output voltage and current. Next one is the output of the corresponding signal waveforms, and this is the output of the controller signals, and this is the IGBT output of the, this is the inverter output voltage and current waveforms. Upper waveform is the voltage and lower is the corresponding inverter current waveform. And also next one is the corresponding motor output using in that design, rotor current and rotor current IB and rotor current IC, and also the rotor current IA, IQ and ID, that is the quadrature and direct axis currents. And next one is the rotor flux, rotor voltage, and also stator current IA, IB and IC also. And this is the LM, rotor speed and electromagnetic torque, and also that waveforms are here given. So the overall motor is controlled by using of the corresponding bidirectional quasi source inverter. So the overall motor is controlled by the using of the indirect field oriented control. Thank you for watching this video.